This is easy digital signal processing, homework 3, problem 9. The homework file shows a set of 8 pole zero diagrams and a set of 8 impulse responses. Try to match the pole zero diagrams to the correct impulse response. Just use basic reasoning. We now first look at diagram 2. It only has 1 zero and 1 pole. So the system is h of z is in the forms like z over z minus c, where c is between 0 and 1. Thus, the impulse response h of n is c to the power of n times u of n, where c is between 0 and 1. It is a monotonically decaying system, so the only possible impulse response is 2. The only possible is 1, because it's monotonically decaying. And now let's look at diagram 8. It's obvious that there are 2 poles outside the unit circle, so the corresponding impulse response should diverges, indicate that the system is unstable. So the only possible is response 4. Let's move on to diagram 3. It has a pair of conjugation complex number and 1 real number poles. So the h of z is in the form like c to the power of 3 and c minus alpha times c minus alpha star times c minus c, where c is between 0 and 1, and the corresponding impulse system is c1rn sine and omega 0t plus phi plus c2 c to the power of n times u of n. The first part is decaying sinusoidal, and second part is like the diagram 2, is monotonical decay. The monotonic decay term moves the decaying oscillation term away from the center. Only impulse response 7 is possible. Now, let's look at diagram 1. It has 1 negative pole and has 1 positive pole. So the h of z looks like z to the power of 2 over z minus a times c minus b, where a we just assume A is greater than 0 and B is negative, less than 0. Then the h of n, the impulse response, is C1 A to the power of n plus C2 times B to the power of n. For this part, the impulse response is like monotonical decay. And for the second part, when n is even number, this is positive. But when n is odd number, it's negative. It's like this. So when we combine these two responses, we can get only impulse response 6 is possible. Let's look at the rest 4, 5, 6, 7 diagrams, because they all have two poles which are conjugation complex numbers. So the h of z looks like z to the power of 2 over z minus alpha times z minus conjugation of alpha, which is alpha star. And the impulse response h of n is like c times r of n sine n omega 0 t plus phi times u of n. There are two parameters that we should pay attention to. One is r, one is omega 0. R means the distance between poles and the original. And omega 0 means the angle. So here, take this as an example. Here is omega 0, and here is r. So the bigger omega 0 means higher frequency. And bigger r means slower decaying speed. Notice that the diagram 7 has the biggest omega 0, and the diagram 4 has the smallest omega 0. So the diagram 7 has highest frequency, and the diagram 4 has lowest frequency, which corresponding impulse response is 3, this is 7, and 5 for the 4. Since diagram 5 and diagram 6 has almost same omega 0, we can only decide from the R. It's obvious that R5 is less than R6. It means diagram 5's corresponding pulse response is decaying faster. So here the response 2 is faster, decaying faster than response 8. So 2 is 45 and 8 is 46. Okay, that's all. That's all the solutions, justifications to the problem 9.